Okay, good morning everyone. I welcome you back to our YouTube channel presenting this wonderful tutorial, is the mentor Hampio Kliman. And of course, if you are interested in registering for personal tuitions, make sure that you inbox me on the WhatsApp number plus 260 and I'll be able to register you for whatever cost, just 100 kwacha each course monthly. We start. We are doing application of differentiation. The concepts I'm going to be using, they apply to every other thing. We find the equation of the tangent and normal to the curve y is equal to 4e to the x at the point. So the equation we have been given, is y is equal to 4e to the x, right? Then we want to find the equation of the tangent and the normal at 0,4. So the first derivative gives you the tangent. So concept, if you want to find an equation of the tangent, find the first derivative. If you want to find an equation of the normal, find the second derivative. How do you go about this? We said dy over dx. What is dy dx of 4 to the e? It is simply 4 to the e x. So gradient 1 is going to equal to, now we have 0 there, so this is going to be e to the power 0. Gradient 1 is going to equal to some 4. Then we know that the equation we use is y minus y1 is equal to m1, then x minus x1. Y minus, what is y1? This is x1, y1, so it's 4. Our gradient is 4, x minus 0, so y minus 4 is equal to 4x. So the equation of the tangent is 4x plus 4. How do we find an equation of the normal? We find gradient 2. m2 is equal to negative 1 over m1. m2 is equal to negative 1 over 4. Same concept, y is equal to, so y minus y1 is equal to m2, then x minus x1. So we use gradient 2 to find the normal, equation of the normal. So this is negative 1 over 4. It's going to be like 0. Sorry, that's supposed to be x. Okay, very interesting. X minus 0. So this is going to be y minus 4 is equal to negative 1 over 4 x. So y is equal to minus 1 over 4 x plus 4. This is an equation of the tangent. The question continues by saying, find also the equations of the two tangents to the curve which are parallel to the normal. So to be able to find an equation which is going to be of the tangent which is parallel to the normal, you shall be using the equation which you used to find gradient 1, then you equate it to gradient 2. Okay? So in this case, let's name it C. Your initial equation was 4e to the x. So in this case, you're going to put your gradient 2 here, then this is going to be equal to 4e to the x. Then you're going to have negative 1 over 4 is equal to 4e to the x. When you cross multiply, you're going to have negative 1 is equal to 16e to the x over 16 over 16. Then e to the x is equal to negative 1 over 16. I want you to notice something. E to the x is a logarithm. Logarithms only obey values that are greater than 0. So e to the x at some point 0,4 is going to give us 1, because if we put 0 while there is x, it will be 1. anything less than 0 is undefined. So in this case, if you notice, e to the x is equal to negative 1 over 16, which does not hold. So there is no equation of the tangent which is going to be parallel to the norm. Okay, such an equation is not really there. Okay, that's really very important to understand. We proceed. Find the coordinates of all the points on the curve. Okay, so let's now try out the other ones we see. So you have been given the function of f of x equal to x to the 2 plus 1 over x. Then your gradient 1 is equal to negative 3. They are saying find the coordinates of all the points on the curve. So to find the coordinates, you just have to find dy dx, the same thing that we're from doing. So before anything, you can manipulate this so that it becomes simple. Then we can find dy over dx. So this is going to be x there, 1 over x. Find dy dx of x plus 1 over x. Now we know that if you have 1 over x, it's the same as x to the power negative 1. So if you're using power rule, this is minus x, negative 1 minus 1, which is going to give us minus x to the power negative 2, which is just the same as minus 1 over x to the 2. So dy dx of x is 1, dy dx of that it's minus 1 over x to the 2. But we already have the gradient, which is negative 3, so you can put it there. Then we have 1 minus 1 over x to the 2. This one can go this side, so that we have minus 3 minus 1 equal to minus 1 over x to the 2. So this negative and this negative can cancel, because whatever you do on the right, you do on the left. Then this you cross multiply, we're going to have 4 x to the 2 equal to 1 over 4 over 4. So you just have to find the values of x. That's the whole idea. This is going to be 1 over 2 or minus 1 over 2. We have found the x points. So the coordinates we are going to have are going to be, the first coordinate is going to be 1 over 2. The second one we need to find, comma. The next one is going to be negative 1 over 2. The second one we are going to find. So we can now get whatever we have, and then we put it in the equation. So f of x was x plus 1 over x when we manipulated. So now while there is x, we are going to put 1 over 2 plus 1 over 1 over 2, which is just the same as 1 over 2 plus 2 over 1. So this into that, it is 1, 1 multiplied by that, it is 1, plus this into that, it's 2, multiplied by that, it is 4. So we're going to have like 5 over 2. Okay, we are going to have like 5 over 2 here. So 5 over 2. Now we find, how about if we use this one? What are we going to get? So this is going to be like f. We put negative 1 over 2. So whatever x values you find, just put them in the original. What you get are the coordinates. So this is the same as f of x is equal to minus minus 1 over 2, then minus 2 over 1. Yeah, should be like that. Common denominator is 2. 2 into that, it's 1. 1 multiplied by that is negative 1, then minus. This is like negative 4, which is going to give us like negative 5 over 2. So if we put negative 1 over 2, we are going to have negative 5 over 2. And this becomes our coordinates. So basically that's the whole idea. That's the whole idea on how to solve this. Quite very, very interesting. Where else? Three, which is C. Says find the equation of the normal to the curve with y is equal to that. Okay, so this is going to be y equal to x plus 4 over x. That's when we find the equation of the normal to the curve with the equation of that. Okay, so I bet the gradient we are using is the same with the one which is in B, because this wasn't given. Okay, let's say the gradient we are using is 3. It's negative 3, right? Yeah, let's just imagine that, because it hasn't been given. Then we can find the x coordinates. So this is just the same as dy dx is equal to, let's see if we can find the x coordinates. Are we going to find them? So dy dx of that is going to equal to, okay, is equal to, this is going to be x. By the way, this question is incomplete, but I'm just trying to show you, if it was given, how you are going to find it. So this is going to be 1 plus, of course, this is going to be negative 4 x to the 2. Like that. Okay. Then you can put your negative 3 there. 1 minus 4 over x to the 2. Then this is going to be like negative 3 minus 1 is equal to negative 4 over x to the 2. Minus 4 is equal to minus 4 over x to the 2. This and this will cancel. Then you're going to have 4 is equal to 4 over x to the 2. You cross multiply. This is going to be 4 to the power 2 is equal to 4 over 4 over 4. So that our x is equal to 1. So we are going to have a point 1, 1, comma. So now let's try to get the 1 and put it in the original equation. So 1 plus 4 over 1, 5. Okay, so this is going to be our x1, our y1. Then we can find gradient 2. So gradient 2 is going to equal to negative 1 over gradient 1. So we can put m1, we can put negative 3 here. And when we cancel, we're going to find our m2 is equal to 1 over 3. Why are we finding gradient 2? Because we need to find the equation of the normal. So equation of the normal is going to be y minus y1 is equal to m2 x minus x1. So this is going to be like minus 5 is equal to, what is m2? 1 over 3. Then this is going to be x. Then this is going to be 1. So y minus 5 is equal to 1 over 3x, 1 over 3. Then of course this is going to be, okay, it's going to be y minus 5. There is no need. Actually, let me just do everything together. Y is equal to 1 over 3 x minus 1 over 3 plus 5. So this is going to be 3. 3 into 3 is 1. 1 multiplied by that. Okay, so let me just find this part here. I don't want to make it like a quadratic, but if I wanted, I was actually going to solve it this way. Three is the common denominator. Okay. Then this is going to be this into this. It's going to be x there minus 1 plus 5. Then you cross multiply, then this is going to be 3y is equal to x minus 1 plus 5. Okay, like that. Then this is going to be 3y is equal to x plus 4 over 3 over 3. Y is equal to x plus 4 over 3. Okay, and that becomes the equation of the normal. Okay, that's how you are able to solve an equation of the normal. Now, this question wasn't complete. I was just trying to show you if you were using the same gradient given on top. Okay, let's try to find question 2. We see how best we can solve. Okay. Application is so interesting. You have to know how to be using these things. Find the coordinates and nature of the turning points. Okay, so I think the coordinates are easy. I'm sure it's the nature of the turning points that are important. Nature of turning points. So here's the thing. Nature of turning points. If at all you were to find dy dx, right? When you find dy dx, which is going to be greater than 0, what you're going to produce is a curve which looks like a cup, and it gives you the minimum point. If you find dy dx, which is less than 0, what you're going to have is the cup which faces upward, which gives you the maximum point. If you find dy over dx, which is equal to 0, just know that your points does not exist. Okay, they are just stationary. So what is the first thing to do? The first thing we are going to do, we are going to find our points. Y is equal to x to the 3 minus 18. dy over dx is equal to 3x to the 2. You put your 0 here. Then you find the value of x. Notice that x is equal to 0. Now we can find the other coordinate. We go directly in the equation. Our y is going to be negative 18. So the first coordinates we are going to find are 0, negative 18 for this particular formula. Now, how do we determine the nature of the roots? To determine the nature of the roots, we find the second derivative, right? So d over dx2 of whatever we find here. Okay, d2 over dx2 is going to give us 6x. Now this 6x, we now put in the 0, which is the x value. What are you going to get? 0. What did we say? If you calculate a 0, by the way, let me just say d2x2, d2x2, d2x2. Whatever you're going to calculate, check. If it is equal to 0, then what you have are non-existent stationary points. Okay? What is the nature of the roots? Stationary. Okay. Just get a new board. I'll solve the last question also. The second one you will solve on your own. The same concept. So let's try to expand this. X to the 2 minus 4x minus 4x plus 16. So this is going to be x to the 2 minus 8. Are we correct? Okay. This is minus 8x plus 16. So we're going to have y is equal to x, then x to the 2 minus 8 there. Then this is going to be like x plus 16. So it's going to be x to the 3 minus 8 to the 2 plus 16x, like that. Okay, let's check if we are on the right track. Okay, so basically this is what I'm getting when I expand this particular equation. Okay. So this is the equation that we have when we expand. It's just that then we now find dy dx of that. Dy dx is going to give us 3x to the 2 minus 16x, then plus 16. Now this point should give us the points that we need because we have found the first derivative. So there's a concept. This part is negative 16, so this is just the same as dy over dx is equal, no need of dy over dx. So at this point we can say this is 3x to the 2. Then we can say which number can we part ways so that when we add them we get 16. Let me see, 4 and 12. So 12x minus 4x plus 16. So negative 12x minus 4x gives us negative 16x. Then what is common is 3x here, x minus 4. What is common here is minus 4. Then x minus 4. This and this are common, so okay, it holds. So we're going to have x minus 4, 3x minus 4, then x is going to equal to 4. X is going to equal to 4 over 3. Okay. Now let's calculate the value, the coordinates. The first coordinate that we had was 4, comma. The second one we're going to have is 4 over 3, comma. So now let's check y is equal to, I'm going to put 4 here. Let's see what we're going to get if it would be sensible. 4 to the power 3. 4 to the power 3 minus 8. 4 to the power 2 plus 16. 4 inside. Okay, so for this particular equation, I'm getting a 0. I don't know. When I put in these values, I'm getting a 0. For this one, let me try the same. Or let me just use the original there, which is, okay, let me put a 4 here. Then 4 minus 4 to the power 2. Okay, this will still give me a 0. So these are the zeros actually. So even this side it will be a 0 because these are zeros. These are the zeros of this equation. So even this side y is going to be 0. These are the coordinates. Now we want to determine the nature. To determine the nature, d2y over dx2. Now where was our equation? This one. We now proceed. So this is going to give us like 6x minus 12. Sorry, what have I gotten? I made a mistake. I got another equation. I wanted the equation where we had already differentiated. I think it's this, yeah. So this is 3x to the 2 minus 16x plus 16. So this is going to be 6x minus 16. Then we get the points. This one, we put it here. Then this is going to give us like 18. Not really. That is 24. Then minus 16, this gives us 8. Notice that 8 is greater than 0. So if 8 is greater than 0, what did we say? Whenever you find something greater than 0, you have a minimum point. So we have a minimum point at 8. We have a minimum point at 8. Then we do the same thing. So this is like negative 8. So here we have a maximum point. So the nature of the roots is we have a minimum point at 8 and a maximum point at negative. So we have a minimum point at 4, and then we have a maximum point at 4 over 3. That's how you solve these particular questions.